Today we are learning NestJS. In the previous videos, we built APIs using Fast API, Flask, and Django. Today we will build a backend using TypeScript. NestJS is a Node.js backend framework built with strong TypeScript support. It encourages developers to organize applications using modules, controllers, services, and dependency injection. This structured approach makes it especially useful when an application becomes larger or multiple developers are working on it. We are going to create a simple courses API with two endpoints, get/courses and get/courses/1. But our main goal is not just to make these endpoints work. Our goal is to understand how enterprise backend applications organize their code. Before writing code, let us understand three important words. Let me switch to cursor. Let me create a file named as sketchpad.txt. So we need to understand three important words: controller, service, and module. So a controller receives the HTTP request. For example, when we request get/courses, the controller decides which method should handle this request. However, the controller should not contain all our business logic. NestJS officially defines controllers as the classes responsible for handling incoming requests and returning responses to clients. Then next comes the service. The service contains the application logic. For example, fetching courses, finding a course, creating a course, calculating a price, communicating with the database. Services are providers in NestJS. Providers can be injected into other classes using NestJS dependency injection. Next comes a module. A module groups related controllers and services. Our course related code will be placed inside a courses module. Later, we could have users module, payments module, authentication module, inquiries module. This keeps every feature inside its own boundary. NestJS recommends feature modules for grouping code that belongs to the same application domain. You can think of it like a company. Controller equal to front desk, service equals operations team, module equals department. So this can be considered like a company. So the front desk, when you go to any visit any office, let's say if you visit any bank, then the front desk is your controller. The one where you inquire is your controller. When you go to the then if you give something for processing, then it is handled by the operations team, and that is called service in uh, NestJS. Finally, a department. For example, one department can be for policies, the other department can be for financial stuff regarding a saving account. So these are called as modules in NestJS. So the front desk receives the request, the operation team performs the work, the department keeps the related people and responsibilities together. Now let's create the NestJS project. So first make sure that Node.js is installed. So the command for the current official NestJS documentation requires Node.js version 20 or later. So open the terminal and run this command. So the shortcut to open terminal is Control and backtick. I will write node version and I get v22.19.0. So this number should be greater than or equal to 20. Now let's install the NestJS CLI. So command to do that is this. I will be using pnpm because it is a faster one and more lightweight. It is more advanced. So pnpm install -g. -g stands for globally. I want to globally install NestJS/CLI. PNPM is not working right now, so maybe I have to install PNPM. Now let me use the previous command. This is not in the path. Maybe I need to reopen the terminal. So let me restart the cursor. It will take some time to open. So there are two different package managers. One is npm and the second one is pnpm. So pnpm is more modern. It is more fast. It is more optimized. You could also install it from npm. That is not an issue. So maybe this is what I need to ask from the agent, or you can search it on the Google. Maybe I need to add this in the path. But okay, so it is unable to install globally. So let's install it for this folder only. So by -G we install it globally. That means from any of the folder we can access this package nestjs/cli. But for some reason it was unable to install it globally. So I installed it locally just for this folder, this real engineering D20 folder. Now let me add a .gitignore file, or maybe I will do that later. Let's create a new application. So this is the command to create a new application named as Nest Courses API. I will be using PNPM. So the minus minus strict option creates the project with stricter TypeScript settings. So NestJS asked us to choose a package manager and I selected npm. Now after installation, I will enter the project. So I will go to cd nest courses API. This you can see this is the project. Now I will start the server. The command to do that is npm start :dev. Or if you are using npm, then it is npm run start :dev. Okay, there were some errors while installing it. So it is asking to consider manual running the failed command npm install minus minus strict peer dependencies equals false. So let me write that command. Let me again try to run this. So what I can do is I will search Google for this error, or you can also use ChatGPT or any other AI tool. I can also try this agents. Let me try it once. I'm not very sure of its output, so I will try to search it on Google also. So let us go through what the agent is suggesting us. It is saying it first thought for 2 seconds. So it understood that I shared a terminal error related to PNPM. Then it is understanding the error. This is a PNPM security feature blocking build scripts for unresolver @ 1.12.2. Running PNPM approved builds will allow the dependency to execute its script. So now it is saying it first thought these two things. Then it is saying PNPM is failing because build scripts or UNRS hyphen resolver were ignored. I will check the project setup and fix the approved builds issue. Then what it did, it read the terminal. So these are the commands that I ran in the terminal. So it could go through all the terminal commands. Then it searched for file, this specific file. it got that in the folder that I'm the pnpm workspace.yaml in the folder that I'm working, real engineering day 20. Then it search files grep attempted. Grep means it tries to find a specific phrase in multiple files. Then again it searched, then thought briefly. So what was its thought? Okay, that is not mentioned here. Then it read package.json from line 1 to 72. The complete file it read. Then what it did? Then it read pnpm workspace.yaml. So this file also it was read. Then it searched for .npm /.npmrc in our folder. Then it searched for again this pnpm workspace.yaml in this folder. Then it read the terminal, the our commands that were there in the terminal. Then it thought something that pnpm workspace.yaml file contains an invalid configuration. The allow builds entry for UNI. Let's open pnpm. Yes, UNI's resolver is incomplete. It is a placeholder from a pnpm improved builds that was never completed. This causes pnpm to ignore the package build script. The correct pnpm 11 syntax for allow builds needs to be found. Okay. Now setting UNRS resolver to true in allow builds will allow the build scripts. I will verify the exact pnpm 11 syntax against documentation. So it got some idea. Now it checked the documentation for the exact answer. Then the pnpm workspace.yaml has an incomplete allow builds entry from pnpm brew builds. I will confirm the correct syntax and fix it. So it told me that I'll find it has some problem and it will search for the solution on the internet and fix it. Then it ran this context 7 is an MCP server. So there it got through the documentation of the PNPM. It is better than simply browsing the internet because it contains the latest documentation of any package. Then it thought briefly. Then it got the solution. Then it again thought briefly that PNPM file needs its placeholder text replaced with UNRS slash hyphen resolver colon true. And what is this UNRS resolver? It is a Rust ESLint resolver with native bindings requiring a post-install build. After fixing a file, npm install will verify the setup. So it thought these things. Then it said to me, the pnpm workspace.yaml has a placeholder from pnpm approved builds instead of a real value. Setting UNRS resolver true and reinstalling. So it made this change in the file. Earlier it was like this, and now it has become this. Then again it thought briefly and ran pnpm install to verify build approvals. So pnpm install was this, and we can see the output that I think it got installed. Done. Then it tries to start the dev server, and as you can see that dev server has been started. So now everything is working correctly. It thought I will provide a concise explanation. So now finally it explains to me that pnpm 11 blocks lifecycle scripts by default, and your pnpm workspace.yaml still had the placeholder from pnpm approved builds instead of an actual decision. So I updated it to this value, and now things are working correctly. That pnpm install completed successfully, and pnpm start dev is running now. So that's great. Now let us also try to run. So that's the benefit of cursor. I will try to run, and maybe it is already running. Sure, so it can give me some error because it has started on port 3000, right? So the Nest app compiled and started on port 3000. So it is already running on port 3000. That's what it is saying, that EADDR in use. that means address is in use. The port 3000 is already in use. So first I need to stop that. Here also you can see that one background shell is running. So what I need to do is I need to close this background process. So I will click on this and press Control and C. Okay, maybe I can't control it. Oh yes, okay, yes. So I think I have to stop it by pressing Control and C. And this is the file change, and I accept this file change. So now we are done with the agent, and we can now try to run the server. Okay, it is still showing some error. 3000 is already in use. So what we can do is we can kill the 3000 port. I have forgotten the command to kill port 3000 exact command. So let me ask it from cursor. The shortcut is Control K. So I want to get it in PowerShell. Maybe this will work. Now let me try it again to start the server. Okay, so great. I think it is running now. Now let me show you the browser screen. So let me open a new tab and go to localhost 3000. And as you can see, we are getting the right thing on the screen. The NestJS CLI creates the initial project structure and provides script for development, building, and production execution. Now inside the SRC folder, we currently have files, these files. app.controller.ts, app.controller.spec.ts, app.module.ts, app.service.ts, main.ts. Let us understand them briefly. First, open src/main.ts. So you should see this code, a similar code like this. This is the entry point of the application. The application starts by loading app module. So let's go to, it starts by loading app module. So let's go to app.module.ts. A module is created using the @module decorator. By this decorator we are able to create module. This root module tells NestJS which feature modules, controllers, and providers are part of the application. For now, we will leave the existing files and create a separate courses feature. So open the terminal and write this. Its shorter version is nest G. Generate can be replaced by single letter G. Now we have got this courses module. Okay, actually we made a mistake. We need to delete this. We had to go inside Nest Courses API. So cd nest courses API, and then I run that command. So now we have got this module courses. Now generate the controller. Nest G controller courses and minus minus no spec. The minus minus no spec option prevents the CLI from creating test files for this introductory demonstration. So controller has been added. This is module and this is controller. Now let us generate the service. So our structure should look like this. Inside the SRC, a course folder is there, and inside the course folder, three files are there: controller, module, and service. This is our one feature. So if we go back to the terminology, it is our one department. Not this is our one feature. Courses is our one feature. Controller is the front desk. Module is the like the department, and service is the operator, backend operator, operations team. And this courses is called as feature. So notice that all course related files are inside the same folder. This is called as feature based organization. So we are following this feature based organization. Instead of keeping every controller in one folder and every service in another folder, we keep related files together. This makes the feature easier to find, understand, test, and modify. Inside the courses folder, create a new file. So that will be course.interface.ts. Now let's add this code. So this interface defines the shape of a course. Every course must have ID, title, description, and duration. TypeScript will now help us detect incorrect course objects while writing the application. Let me save it. Now let's build the courses service. So open src slash courses slash courses.service.ts, and then update its content. Let us add. So we are importing course from course.interface, and then we are creating an array of course, and then we are defining the different methods. Find dollar, find one. So at the rate injectable, let us start with this. This decorator tells NestJS that this class is a provider. It means NestJS can create an instance of this service and inject it wherever it is required. So at the rate injectable decorator tells us that this class is a provider. That means it can be injected wherever it is required. So we do not have to manually write const service equal to new course service. NestJS manages that object for us through dependency injection. So we created this temporary in-memory data of three courses. It is useful for learning, but it is not a database. Whenever the application restarts, the array returns to its original state. Later, the service can communicate with PostgreSQL, MongoDB, Prisma, or another data access layer without forcing us to rewrite the controller. Now, this find all method, this method returns all courses, and find one method, this method searches for a course with using its ID. If a course does not exist, we throw not found exception. NestJS converts this exception into an HTTP 404 not found response. The important point is that the searching logic is inside the service, not the controller. Now let's build the courses controller. So let us update the code. Let us understand this carefully and we will then resolve the error. So at the rate controller courses. So we are importing, before that we are importing these things from NestJS/common and these things course service and course from courses.service and courses.interface. Then at the rate controller decorator. This means every endpoint in this control begins with /courses. When we write courses inside at the rate controller decorator, that means every endpoint inside this controller will begin with /courses. Now look at this constructor. We are saying this controller needs a courses service. NestJS reads this information and injects the service automatically. This is dependency injection. The controller does not create the service. NestJS creates and manages it. This reduces tight coupling and makes the code easier to test and replace. So by this line, we are simply saying that we need a courses service. So here we have put this injectable decorator. This means that it can be dependency injected. It can be injected wherever it is required. So here it is required in courses controller, and we are injecting the service here. The benefit of dependency injection is that the tight coupling is reduced. It makes it easier to test and change the code. Now this method is get, and because the controller path is courses and the method has at the rate get, this handles get/courses. The controller does not directly access the array. Instead, it asks the service this dot course service dot find all. Then second is get one course. This creates a dynamic route get/courses/1, get/courses/2, get/courses/3. We receive the ID using at the rate param and this thing. By this, we are getting the ID. URL parameters normally arrive as strings. Parse int pipe converts the parameter into a number. It also rejects invalid values such as courses/abcd. Finally, we pass the ID to the service. So we say return this dot course service dot find one. So this is we are calling the method of our service with the ID. Now let us try to resolve this error. So what is the problem? A type referenced is a decorated signature must be imported with import type for a namespace import. So maybe we need to put type here. Okay, now let's understand the courses module. So this module connects the controller and service. So controller says courses controller. This tells NestJS this module contains the courses controller. And in the provider's way courses service. This tells NestJS create and manage the courses service inside this module. NestJS module define which controllers belong to a feature and which providers can be injected inside that feature. So NestJS modules define which controllers belong to a feature. This courses is a feature, and we have a controller inside it. Now module tells us like which controller belongs to this feature and which providers can be injected inside that feature. So it is telling that courses controller is our controller for this feature and courses services is the provider that can be injected into this controller. So providers are encapsulated by their module unless they are explicitly exported. So providers are encapsulated. Encapsulated means just like a capsule contains a lot of particles inside it, but a very good packaging is there. So simply that is encapsulated by their module unless they are explicitly exported. So that means this service cannot be used by any other controller of some other feature. This can only be used by this courses controller, no one else. But if I explicitly export this service, like I am not exporting, so maybe I will give you an example later. But as of now, we can have an understanding that this courses service can be injected only in courses controller. Now let us register courses module. So let's open src app.module.ts. So app module is the root module. By replacing courses module inside imports, we connect the courses feature to the main application. So this kind of relationship is there. App module is the root module, then contains the courses module, and it has course controller and course service. I hope things are clear to you. In case you have doubts, please mention in the comments. I will explain in very detailed manner. I also give you examples. Now let's touch the API. First, ensure that application is running. So I think it is not running as of now. Let us restart it. It is saying 3000 is already in use. So let us fill the port. Now let us go to the browser and let's type /courses. So we are getting the right response. Now let us try /courses /. So again we are getting the correct response. Now test an ID that does not exist. Maybe 99. So it is giving me not found error. It is code 404. Now let us type some random string, not necessarily a number. So it is giving us correct response that status code is 400. My request is bad request because the number is expected. Because we use parse int pipe, so NestJS should reject the request with a 400 bad request response. Now our application is small, but we've intentionally separated the responsibilities. So request flow is when the browser sends get slash courses slash to. The flow is HTTP request makes goes to courses controller. Then let me write this flow. So this is the complete flow. HTTP request goes to courses controller, then goes to courses service, then course data is fetched, then again course controller uh, receives the course data and it sends back as the JSON response. The controller handles HTTP related work. The service handles application related work. The module connects and organizes them. So these are the three key things that you must remember. So a question can be why not place everything inside the controller? Technically, we could write everything inside the controller. For example, we could write like this. So this is keeping everything inside the controller. So it is actually not a good practice because um, imagine the same controller later needs to query a database, check course availability, calculate discounts, verify permissions, send notifications, record analytics, call another service. The controller would become extremely large. That is why we keep controllers thin. A controller should mainly receive do these four things. So it should receive the request, read parameters or request data, call the appropriate service, return the response. That's it. The service that contains the actual application logic. So a larger courses feature might look like this. So this is our simple courses feature with just 4 files. But a larger courses feature can look like this. The courses, then another folder DTO which contains two different DTOs. DTOs means data transfer object. Create course.dto, update course.dto, and entities can be there. Course.entity.ts. Then repositories can be there. Then controller service module. Then its spec are for testing. Test files could also be there to test the service of courses. So DTOs means data transfer object. DTOs define and validate the data accepted by the API. And here we have used two DTOs for create course DTO.ts and update course DTO.ts. Entities represent database records or domain objects. Repositories handle database queries. For example, course service can fetch courses repository and that can get the data from the PostgreSQL database. Guards can also be there and guards can check authentication and authorization. For example, only an administrator can create a course. Then pipes can also be there. So I'm adding more files to it. Like guards can be there, pipes can be there. So what pipes does is pipes transform and validate request data. We have already used one, like parse int pipe. Then interceptors can be there. So interceptors can handle concerns such as logging, response transformation, performance measurement, caching. This separation allows different developers to work on different areas without placing the entire application inside one file. Now finally let us discuss common beginner mistakes. First is forgetting to register the module. So you may create courses module, but forget to import it inside app module. So you need to check this file app.module.ts and ensure that this imports courses module is this line is there. The next mistake is forgetting @injectable. The service should have @injectable or decorator. Without it, NestJS may not manage the service correctly as a provider. So this is necessary to place it over this courses service. Else we cannot inject it inside the controller. Nor can we place it here. Next mistake is forgetting service and providers. So we need to put the service in the provider. We need to ensure that it is written here. Then next mistake is creating the service manually. Avoid doing this inside the controller. Uh, never do this. Never do this inside controller. So we must use constructor injection. Use constructor injection, and this can be like this. So this is called as constructor injection. Then fifth mistake is comparing a string ID with a number. Without conversion, the URL parameter 1 is a string, while the course ID is a number. So we need to use this parseInt pipe as done here. So this at that param and this thing tells that convert this ID into a number. Then mistake 6 can be putting all the logic in one controller. In the controller, we need to separate the HTTP logic and application logic. So this may work initially, but it becomes difficult to maintain. Keep the controller thin and move application logic into services. Today we created a NestJS backend application. We learned that controller receives request, service contains application logic, module organizes related features, dependency injection connects classes, and we created get/courses route and get/courses/id route. The most important lesson is not only how to return course data, the important lesson is how to organize backend code so that it remains understandable when the project and development teams grow. So task for today. Add a new method to the service. Add this method. Then create an endpoint. Create this endpoint. The endpoint should return courses matching the requested duration. Then also add one more course to the array and test all situations. So one is valid course ID, other is invalid course ID, and third one is invalid non-numeric ID.